Okay, finite math students. This could be a long video. I'm only going to work on one problem, but it's a pretty challenging problem. It's actually problem number 10 in your Simplex Algorithm Test. And I am assuming everyone in the class is doing the homework, keeping up with the homework, and doing what you're supposed to do. I don't want to get emails from anyone to the effect of, well, I can't do the work because I was diagnosed with COVID. Or I can't do the work because I'm working 80 hours a week and, my grandmother died. Okay. If things are really that complicated for you right now, you don't belong in school. Then you need to take a semester off. You need to take a semester off and you need to get your personal affairs in order before you try to study something difficult at college. College is not easy. It's not supposed to be. Because if college was easy, a college degree would not mean anything. It would be worthless. So college is supposed to be hard. It's supposed to be hard for a reason. If it was easy, well, then everyone, would have a PhD, right? So college is a lot of work, and you know what? It's supposed to be a lot of work. And if your life is very complicated right now and you don't have the time to study, I understand that. But then you need to take a semester off and figure out how to solve your personal problems. And then, when things are better for you, when, you're making money and you're healthy and you're happy, that's the right time to go back to college. Okay? If your life is a disaster, that's not the right time to go to college. In fact, that's the right time to drop out of college and tell yourself, hey, I'm going to go back next year, next semester, next year, whatever. But I'm going to be very frank with you. I get very tired of students sending me their belly aching emails. We all have problems. I'm not your fairy godmother. I don't have a magic wand. I don't know any magic spells. And I'm not Harry Potter. I don't know any magic spells that can make your problems go away. If you can't do the work, then either drop out, take the course again some other semester, or be an adult and just accept your D or your F. And that's all I can tell you. But I'm not going to give you an A or a B just to prove how nice I am. That is not going to happen. So I get tired of some of the belly aching from students. It's very manipulative is really what it is. And the assumption is that your teacher is a big sucker. And I can tell you right now, I am not a fool and I am not a sucker. And I don't like it when students play that manipulation game with me because it's really embarrassing. I think it's embarrassing, especially for the students. Okay, so with that said, let's go through this problem. It could very well be the hardest problem on your test. So I'm going to show you two different ways of solving this problem. Now, the people who wrote the test are telling you to use the big M method to solve the problem. All right, they're telling you to use this particular method to solve the problem. Excuse me. They're telling you to use the big M method. I'm going to show you two alternative approaches. You don't have to use the big M method. If you want to use it, you can read about it. It's part of your textbook. Okay, it's in your textbook. But we don't have to use this method. There are two other approaches. Excuse me. The first approach that I'm going to show you is actually a variation of the simplex algorithm, and it's pretty complicated. The second approach is a lot easier. I'm going to show you both, use whichever approach is going to be easier for you. All right. Okay, so first of all, we have a minimization problem here. And the problem is, this is our objective function, and these are the constraints. These are the constraints. So we see here a mixture of constraints. This is less than or equal to, this is greater than or equal to, this is an equality, okay? What I'm going to do is I'm going to split the equality up into two constraints. So I have 2x1 plus x2 minus x3, and that's going to be less than or equal to 1. And I also have 2x1 plus x2 minus x3 greater than or equal to 1. And that's perfectly okay. That's perfectly legitimate. So all I'm doing is I'm taking that restriction, 2x1 plus x2 minus x3 is equal to 1, and I'm breaking it up into two different inequalities. Okay, 2x1 plus x2 minus x3 is less than or equal to 1, and 2x1 plus x2 minus x3 is greater than or equal to 1. Okay. So how are we supposed to do this? Well, if you've been doing the homework, you would know that we need to create something called a tableau. All right, we need to create a tableau, which is really just another name for a matrix. Okay, so we're going to start that. Actually, let me write this down so that you can see what I'm doing. So what I have is x1 plus 2x2 plus x3 plus slack variable 1 is equal to 8. And then I have 2 times x1. Maybe I could move that over. Well, okay. 2x1 plus 3x2 plus x3 minus a surplus variable. Remember, if you have a greater than or equal to constraint, you have to subtract a surplus variable instead of adding a slack variable. So remember, guys, this right over here is a slack variable, and this right over here, all right, that is called a surplus variable. All right. Okay, so that's going to be equal to 6. And then, of course, 2x1 plus x2 minus x3 plus slack variable 3 is equal to 1. And then we have 2x1 plus x2 minus x3 minus s4. Oops, sorry. Minus s4 is equal to 1. Because remember, I took my equation and I broke it up into two inequalities. One is less than or equal to, one is greater than or equal to. So one of them will get a slack variable and one of them will get a surplus variable. And then finally at the bottom, I have 4x1. I'm looking at my objective function right here. 4x1 plus 13x2 minus 16x3 plus C is equal to 0. Okay, so that's plus 4. So all I'm doing is I'm moving these values to the other side of the equality symbol or equals sign. Okay. So then I have 4x1 plus 13x2 minus 16x3 plus c is equal to 0. Okay, fantastic. So matrix is equal to 1, 2, 1. Slack variable 1, okay, slack variable 2, slack variable 3, slack variable 4, and then C, and then 8. And then I have 2, 3, 1, slack variable 1, slack variable 2, slack variable 3, slack variable 4, C, and then 6. I'm looking at the third row. 2, 1, negative 1, slack variable 1, slack variable 2, slack variable 3, slack variable 4, C, and then 1. Okay. I'm looking at the next equation, so that's going to be 2, 1, negative 1, slack variable 1, slack variable 2, slack variable 3. There's a surplus, this is a surplus variable, which is basically a negative slack variable, and then C, and then 1. So remember, a negative slack variable, you could call it a negative slack variable, but it's really the same. It's usually called a surplus variable. It's the same thing as a surplus variable. The last row is 4, 13, negative 16, slack variable 1, okay, surplus or slack variable 2, S2, which is really a surplus variable. And wait a minute, I'm talking and I should be concentrating what I'm doing. So S1, S2, S3, S4, C, and then we have 0. Okay, so that looks pretty good. Let me make sure this is really what I want. So 1, 2, 1, let's see, 2, 3, 1, 2, 1, negative 1, 2, 1, negative 1. So let me see here. 8, 6, 1, 1, 0. Yeah, everything looks pretty good. Now the problem is, guys, we have a negative 1 right over here. We have a negative 1 right over here. So that's not good. We need to get rid of those negative 1s. So I'm going to pivot right over here. I'm going to pivot right over here on the positive number that is furthest to the left. And I'm going to have to do the same thing eventually down here because I can't have these negative 1s here. All right, so let's see, matrix. Yeah, second row multiplied by 1/2 times, remember a space means times, or you could just enter the times symbol. Your choice, you could just type a space, enter a space, or enter times for multiplication. Matrix 2, and let's see what that looks like. Matrix form. Okay, so there's a 1 here, yes. There's a 1 here. And now matrix first row is equal to matrix first row minus matrix second row. Now, why am I doing that? Because I want this number here to be 0. Well, 1 minus 1 is equal to 0, right? 1 minus 1 is equal to 0. Okay, so matrix, first row of the matrix minus the second row of the matrix. That's going to be the new matrix, the new first row of the matrix. Okay. The third row, what's that going to be? That's going to be the third row minus 2 times, or 2 space. The space means multiplication, times the second row. Okay, so we can see this column is starting to really shape up. And then the fourth row, how is that going to change? It's the fourth row minus 2 times the second row, because the second row has that canonical 1. I keep referring back to the second row because the second row has what is called the canonical 1. This is the first row, second row, third row, fourth row, fifth row. Okay. So let's see, the new fourth row is going to be, okay, fourth row minus 2 times the second row. Okay. The fifth row is going to be the fifth row minus 4 times the second row. Okay, so now I've made some progress. I need to see what I've done. So this column looks fantastic. All zeros except for a single 1, which is what I was going for. Excuse me. So the first column, excuse me, I think I need a drink of water. Hold on 1 second. Okay, so the first column looks fantastic. I have all the zeros except for a single 1. That's exactly what I wanted. This column here looks good, all zeros except for a single 1. This column looks good, this column looks good. Uh-oh, we have a problem right here. There's a -1 here. This should be a +1. All right, so let me show you something. +1, that looks good. +1, that looks good. +1, that looks good. +1, that looks good. Uh-oh. That's a -1, so that's something we have to work on before we can even implement, you know, the real simplex algorithm, okay? So let's work on that. Okay. So what we're going to have to do, guys, we're going to have to pivot right over here on the +1. We're going to have to pivot right over here on the +1. Remember, one of the rules of linear programming is that you cannot pivot on a negative number. You cannot pivot on a negative number. So you cannot pivot on -2 here. You cannot pivot on -2 here. The only other choice is to pivot right over here where we see the +1. All right? Okay. So we are going to pivot right over here. And that should be pretty easy to do. All I have to do is multiply the row by -1, and if I multiply the row by -1, this becomes 2, this becomes 2, this becomes a -1, which doesn't matter because this column is not a basic column or a canonical column. this becomes a positive 1, and this becomes a positive 5. The reason I seem distracted is because I'm just looking at some of these other values, but we should be okay, although the problem is here we do have a negative 5, and that is definitely a problem. Okay, but let's worry about that later. Let's worry about that later. So, yeah, we do have an issue over here because we have a positive... you know what? We do have an issue. Hold on one second. Right over here, if you look at this basic column, it's equal to negative 5. And that is definitely going to be an issue. So we are going to have to pivot over here. We still have a lot of pivoting to do. Okay? So, but that's okay. So let's see. We are going to multiply the fourth row of the matrix by negative 1. Okay, that looks fantastic. Now the problem, like I mentioned before, so don't worry about the negative 12 here. We're not going to worry about that value. But I am concerned about this particular column because this value, this variable is equal to negative 5. So we have x1, x2, x3, s1, s2, s3. So right now s3 is equal to a negative 5, and that's not a good thing. So we are going to have to pivot. Hold on one second. If we pivot here on the 1, this will remain a negative 5, and that's really not what we want. So actually, we are going to have to, in order to make this a positive number, we are going to have to pivot on a negative value, which is normally not what you do in these problems, but in this case, I don't think we have much of a choice. So what I'm going to have to do in order to make this a positive number, I am going to have to pivot on one of these negative 2's. It really doesn't matter. Usually you choose the column that is furthest to the left. So this is where I'm going to pivot. All right, so let's see if that's going to help us. Normally you don't pivot on negative values, but in this case we really don't have a choice. Because right now S3 is equal to negative 5, and that doesn't work. Okay, so let's see. This is the third row. So that's going to be equal to negative 1/2. Oh, but then the problem... Okay, this should work. So negative 1/2 times the third row. And that will give me a positive 1. Okay, that's very good. So now I have a positive number over there. And then the first row is equal to the first row minus 1/2 times the third row. And now the second row is equal to minus, okay, the second row minus 3/2 times the third row. And And now we have the fourth row is equal to the fourth row minus 2 times, or 2 space, the same thing. The third row and now the fifth row is equal to the fifth row, the fifth row minus 7 times the third row. Okay, now let's see what we have here. We have to make sure our basic variables are 0 or positive. So let's see what we have here. x1, oh, here we have a problem because x1, x1 is equal to a negative 3/4, and that's not going to work. Okay, so that's not going to work. So we're going to have to pivot right over here where it's -1. Everything else looks pretty good. So this column, of course, looks good. This column looks good. This column looks good. This column looks good. The only problem is right over here. x1 is equal to a negative 3/4. x1 is equal to a negative 3/4. There we go. But that's not acceptable because in the problem it states that all the variables must be greater than or equal to 0. All right, so in order to address that issue, we know what? We're going to have to pivot here on the -1. We're going to have to pivot here on the -1, or actually, yeah, let's see if that works. Okay, let's see if that works. So, or we could try pivoting. Let me see one moment. Instead of pivoting on the -1, let me try pivoting here, right over here on positive 1/4, because really it's not a great idea, guys, to pivot on negative values. So let me try to pivot right over here on the positive 1/4. All right, so then the second row is equal to 4 times the second row. Matrix form. Yeah, but we're still going to have that -3. Now we have a -3, but that's not, it doesn't solve the problem because we're still stuck with that -3. So what we can do, let me go back to this previous matrix right over here. So matrix, okay, 2 is equal to 1/4 times matrix 2, matrix form. Okay, we have the same matrix that we had before. So pivoting here doesn't really change the negative. So we're going to have to pivot right over here on the -1. Okay. So then matrix 2 is equal to negative matrix 2, matrix form. And then, let's see. Okay, and then the third row is equal to the third row minus the second row. Okay. And then finally, the fifth row is equal to the fifth row plus 25 times the second row. Okay, so now let's see what we have. This is a basic column. And here, okay, so here we have x1 is equal to 0. We have x2 is equal to 7 over 4. Oops, 1 second. We have, okay, we have x3 is equal to 3 over 4. x3 is equal to 3 over 4. And what about our slack variable? So this is x1. It's a non-basic variable, so by default it's equal to 0. x2 is equal to 7 over 4. x3 is equal to 3 over 4. This is s1. s1, or the first slack variable, is equal to 15 over 4. S2 is equal to 0 because it's a non-basic column. S3 is also equal to 0 because it's a non-basic column. Okay, this is S4. Okay, S4 is equal to 0. S4 is equal to 0. And then C is equal to negative 43 over 4. Okay, so we have a feasible answer. I don't know if this is the optimal answer, but it is a feasible answer. What's tricky about this problem is that when you're doing most linear programming problems, guys, you are not allowed to pivot on negative values. This problem is very tricky because in order to arrive at a feasible solution, sometimes you must pivot on a negative entry in your matrix, which sort of violates the rule that you learned at the beginning of this chapter. So it is really a little confusing. This is not a trivial problem. This is actually a very complicated linear programming problem. Okay, so now this is a minimization problem. So when you're doing a maximization problem, okay, you want all of these values to be 0 or positive. When you're doing a maximization problem, you want all of those numbers in the bottom row. Don't worry about these values here. But when you're doing a maximization problem, you want these numbers to be 0 or positive. However, look over here. Look over here. Okay, we are doing a minimization problem. So here the rules are going to be different. We know we have reached a feasible and minimal solution when all of the values in the bottom row are either 0 or negative. So this is our answer. This is our solution. Okay, let's see what Pearson has to say. The minimum value is going to be C is negative 43 over 4 when x1 is 0 and x2 is 7 over 4 and x3 is 3 over 4. Okay, my dog is going really nuts here. Sorry about that. He's barking his head off. Check answer. Okay, terrific. So it says here, your input is correct. Score 100%. Yay. Okay. Now, I realize, guys, this is a very, very challenging problem for most of you. So I'm going to show you. Chachki, it's okay. We're going to go outside soon. Just relax. That's my dog. He's barking because I think he wants my attention. Okay. I'm going to show you a Mathematica shortcut that will enable you to arrive at this same answer, but with significantly less work. Okay. Minimize negative 4x1 minus 13x2 plus 16x3. And these are my constraints, x1 plus 2x2 plus x3 less than or equal to 8. And this is the symbol for and. When you study computer programming, guys, the double ampersand usually means and. 2x1 plus 3x2 plus x3 greater than or equal to 6, and 2x1 plus x2 minus x3 is equal to 1. Use the double equal sign, please. The double equals sign is very important. Do not use the single equal sign. That means variable assignment. You please use the double equal sign. And x1 is greater than or equal to 0, and x2 is greater than or equal to 0, and x3 is greater than or equal to 0. And I'm looking for x1, x2, and x3. Okay? Notice that I have exactly the same answers. I have exactly the same answers. So right over here, this shows me the minimum value of the objective function, which is negative 43 over 4. Negative 43 over 4. x1 is 0, x2 is 7 over 4, x3 is 3 over 4, and that was so simple, right? So what have you learned in this video? Okay, we've learned that technology is amazing. We've learned that computer technology can simplify some very complicated, very difficult math problems. We also learned that in this chapter, you are not supposed to pivot on negative entries in your matrix. However, when you're solving a problem like this is called a mixed constraint problem. When you're solving mixed constraint problems, sometimes you don't have a choice. Sometimes you must pivot on a negative entry in the matrix, because otherwise you will never arrive at a feasible solution. Remember, feasible solutions in linear programming are always non-negative solutions. You cannot have, your variables cannot be equal to negative numbers when you're doing a linear programming problem. And that's just how the cookie crumbles. Okay, all right guys, I think this video is long enough. Hopefully you learned something of value from the video. Have a good Thanksgiving and good luck with your test.